Hello everyone, welcome to my channel. So in the previous video, we discussed about how to use generative AI activities and create responses that are more relevant to your context. But in the video, we focused on a simple example, which is a single email. But that was a specific email that we selected. But in reality, we work with a lot more data in an organization. So, how do we understand this? So, in an organization, it's not just one data point that you're dealing with. You have to work with a lot of data that comes from various different sources. And this could be documents such as contracts, policies, reports, or any other document that you have in your organization. Or else it could be emails or any communication tool. In addition, you also have a bunch of applications that you're dealing with every day, like ERP systems, CRM applications, and many more. All of these applications contribute to your day to day activities and they provide different types of data in different formats. Some of them will have maybe structured information, and some of them, like documents, will have a lot of unstructured data. But the challenge is, how do we find the related information from all of these sources? So far, we focused only about a data point that we already knew and we knew how to respond. But in scenarios like this, where you have the data but in different sources and you don't really know where this information is, maybe, let's say, for example, you're looking for some data and that could be available not in just a single document, but it could be available in multiple documents and maybe also in some application. So in such scenarios, you need to identify all the related information from wherever that information is and then retrieve it, then generate a response using GenAI solutions. So this is where the challenge of data comes in for AI applications. So how do we address this? We can address this using context grounding. So what is context grounding? In simple terms, context grounding is a process of narrowing down this entire data set into what we really need. The most relevant data set that you can find from your entire data set and using that as the context for your GenAI models to generate a response. So this process of filtering all this information and retrieving them and providing that as a structured context for your application is a process of context grounding. So basically it has like three to four things. First, actually, you need to load this information into a place. So that's the first step. Second, identify all this relevant information, retrieve this relevant information, and generate a context. So altogether, four stages. So why it is really needed? It's because relating back to the previous recording that we did. So in the previous recording, we kind of used email as an example to generate a related response. But without providing the context, it was just generating a random response. But the moment you provide the data, then it was able to give a more relevant and more helpful response. So this is where context is helping. So what are the benefits of using context grounding? So basically, when you are dealing with language and a lot of data, there can be scenarios where certain information relates to multiple things, but to which exact thing it relates to, that comes with context. So when you provide context, it avoids ambiguity in your data and it actually helps to provide more complete and relevant information. It also improves the accuracy, as you see in the slide. And once you provide a more related data through context, it also helps to reduce the token number of tokens that you use. Like for example, let's say you have a big data set and you don't really know what is related to this query that you're getting, and you're feeding all this information into your model. That means you're giving a lot of unnecessary data along with the little relevant information. So that gives you additional cost, and it also takes time to process all this unwanted information. So instead of that, using context grounding or this process, you can actually reduce this unwanted information and just get the relevant information and then generate a response on top of it, which helps to reduce the cost, and also improves the efficiency. And yeah, so basically it's a process of handling large volumes of data. So it addressed the fourth point based on what I have been exploring so far. So this context grounding in total, it's a combination of multiple things. And if you really go one step below of context grounding, how to see how it really works, is actually a concept of retrieval augmented generation. It's in short, you can call it RAG. So below all of those things, below that level, RAG is what actually helps to create these kind of solutions. So RAG is a process of combining retrieval and generation of responses together by introducing a vector database and a process of transforming this data called embeddings. So basically, when we are dealing with RAG or context grounding, we don't deal with like only text. This text is actually stored in a different format called vectors in numeric form. So it uses a different database called a vector database, where it actually can store the text version of it and the numeric version of these text, which you will be using to match and find the more relevant information. So it's the numbers that you are using to find the information. So how do we do the retrieval? So so as I mentioned, in RAG, there are two components. One is retrieval, the other one is generation. In retrieval, it uses a search in this vector database to identify the relevant info and extract them to your memory so that it can use them as the context to generate a response. So once you identify it, then it uses your selected generative AI model or a large language model, and based on the information you have provided and based on the instructions you have provided, it will generate a relevant information. So this whole process is called RAG. So let me help you with trying to understand this or try to explain this in a diagram. So in this diagram, this kind of explains how RAG works. But before going through each and every thing of this, let me take a highlighter here. Yeah. So every RAG solution has two paths to it. Before you actually retrieve the data, you first need to load this information and do the conversion to embeddings. So this data loading part is mandatory when you're working with RAG. Because say that you get all this information from like hundreds and thousands of documents. You cannot go to these documents, and every time you have a query, you cannot keep querying these documents. It takes a lot of time, and these documents can be huge. It can have like 500, 600 pages, we never know. And sometimes you might even need to use OCR engines to extract text from this. Or maybe you have different images. So it's very costly to do that every time. And that's why this vector database is actually helping, because you can do that once and you can store this information and you can use it anytime. So this is a process of data loading. So in a RAG solution, this is the part that you first need to focus, this section. So basically what you do here is you identify the data sources and you find ways to load this information or retrieve this information from those sources, then identify ways to create embeddings or do the data chunking and to store them in a data warehouse or a data vector database. So why do we need to break this into multiple chunks? It's because, let's say you get a document of 10 pages. Do you really need to store that entire 10-page text as a one record? No. Because again, when you do that, when you store that entire document as one record, then that means you are providing that entire document as the context to the model, whereas only a portion of that document could be really relevant for different queries. So you need to identify these methods and break it into chunks. For example, you can break it into like one page chunks. So you have 10 pages. Every page is a separate chunk so that you're actually using only a small portion of that data to provide as the context. And how does that helpful? How can that be helpful? Is because you're providing less data that are only relevant. And through your vector search and through how this RAG works, if your data, if you have relevant data in multiple chunks, all that will be anyway provided. So still there is a way of reducing unwanted information and only using the related data. I hope that part is clear, but if you can tell me in the comments that if anything is not clear, I can explain this in a follow-up video. But this is the first part of a RAG solution. So this is the first. Second step, once you have all this data in a vector database, then you can start querying. So the second part is actually comes from here, this section. This is where your model comes into play. So what do we do here? So when the user provides a query from any interface, it could be a chat interface, it could be another automation that you're providing just a query. What happens in the background is it actually converts that query into an embedding, because in the vector database, you have this data in the embeddings form. And as I mentioned before, we are using these embeddings to find the relevant information. So first you convert this to an embedding and then you send that information to the vector database. Then through the vector search here, it will identify all the relevant information as the context, and that will be provided to the model over here. So from this process, you get the context, and from here, you are sending the same text version of the user query, and then you have multiple information in your model. So in the model, what do we have? You have the instruction set, which is by default. In the instruction, you are saying this is how you should process the data that it retrieves. Then you have the user query, and then you have the context. So you have three types of information, and using that, it generates a response and gives back to the user. So that's in very high level, in simple terms, that's how RAG works. There are multiple things involved in this whole RAG process. There are so many other things that we need to understand, but we'll take it one step at a time. So this is the basic RAG concept. Having that understanding, now let's see how we can actually implement a simple RAG solution using UiPath GenAI activities and also context grounding. Okay, I have three documents here, and these are just random documents that I downloaded from the internet from different platforms. All this is related to some research that was done. So basically, these are research articles. So if you see here, all these are research papers that was done about COVID. So what I'm going to do, let's say our use case is managing these research papers so that people can easily query the data from these research articles, right? So you can see these are very it has a lot of information. It's very unstructured. And let's see how we can use a simple solution. Let's build a simple solution using these three documents. First of all, now as I said, we need to find a place to store this information as a vector database, right? So how do we do it? In UiPath, first of all, there is a so in UiPath you have context grounding. In context grounding, there are two things that we need to configure. First, you first need to load this data. Let's say these are coming from a shared drive. I'm not referring to like OneDrive, Google Drive. Let's say it's in a local shared drive. In that case, you need to load this information um, to a orchestrator storage. So you can simply write a process or automation process where you load this data into a storage bucket. Because for context grounding, storage bucket is one source. So for our scenario, just to keep it simple, because this is the first video, let's create a simple storage bucket. So I'm going to create an orchestrator storage bucket called documents. And this is my storage bucket, and this is available in my GenAI folder. So the first step is done. Now let's try to load some of these documents into a storage bucket. For the time being, let's do it manually. But you can always do that in your studio workflow. You can read these documents and you can use the activity, this upload storage file, to load this data into a storage bucket automatically through your process. So it's a very simple process. For the time being, I'll show you how to do it manually. So let's go here and let me browse for a file. So I'm going to add the first one. And then I'm going to add the second one. I'm not adding the third one because I want to use that for another example. For this video, we'll just use these two documents. So this is the first step. So you created the storage bucket, then you loaded the data to that storage bucket. Now we need to do one more thing. So we have the storage bucket ready, but we need to load this information to an index. Index is kind of like a vector database that you have in UiPath, which is called the context grounding. So how do we do that? To do it, in your automation cloud, you can go to admin, then you can go to AI trust layer and click on this context grounding. So this is the place where you do your index creation. So in my case, I have the storage bucket in my GenAI folder. And I'm going to create an index now. Add new, and let's say this is my index. Let's say demo index. And so we have two sources here. One is a storage bucket. Another one is a IS connection. So IS means integration service connection. So this can give you access to all the other external sources. But for now, let's focus on the storage bucket. So I'm going to use my GenAI folder here, and my storage bucket is the documents bucket. So we can have multiple file types. So these are the supported file types for the time being. So I'm using all as a setting because it's easier. And then click on sync now. What happens when you do this is it runs a process in the background to get the data from the storage bucket, and it does that chunking and embedding on its own. So you don't need to worry about it. and it will load your index based on this process. So this whole process will actually take a while based on how big your data set is to update the vector database. So that's your next step. And once you have this, then your data is ready to be queried. So this is how you load the data for the initial time. And you may have a question like, here you loaded the data, but next time, let's say there are changes in your actual data source. How do we configure that? We'll focus on that in a separate video. So this part is ready, and now let's go to Studio to actually try and consume this. So again, in my Studio workflow, I'm using the same activity as I used in the previous video, which is the UiPath. This is the activity package, UiPath.integration service activities. And I'm using the UiPath Generative AI activities. So I'll keep the flow very simple for this one. So I'm getting the data, the user query from input dialog. As I mentioned in my previous video, this data can come from a user query that is happening in a web application, or it could happen in a UiPath apps. The source can be anything, or it could be any automation process. So once you have your user query, we are going to use this activity, content generation. This is a part of the integration service activities, which actually helps you to process your query, get the data from context grounding, and generate a response in one go. So in a single activity, you can do all that. So how do we configure this? First setting is to select the model. And let's say I'm using GPT-4o. And my prompt, this is the user query. So for in my scenario, this is the user query variable. And then I have the PII setting. So let's keep it to false because that's not relevant. And then you have the system prompt. This is the default system prompt. Maybe I can just simply change this. Uh, because this can actually help to retrieve the data. So this is a very example instruction, but there can be much more structured instructions as I did in my previous video. And yeah, so this is just an example that I'm providing. And then comes the most important setting, the context grounding. So by default, it's set to none. I'm going to use existing index. So there are two options here. One is a file resource, which again, for another video. But here I'm using the existing index. And then I need to tell in which folder I have this in GenAI. And now we can see the demo index. So let's select that. And what this means is how many results that you want to get. So basically, in a vector search, you can have multiple responses. It's not like a regular database where you actually specify multiple conditions and you just get only the selected record. There also can be scenarios where even in a regular database where you get multiple related responses, right? So it's a similar thing here, but here you can limit how many results that you can get. So how many do you need for your response generation? By default, it's 3, and this can be tuned according to your use case. So you can say 3, you can use 5, depending on how you want to use it. So let's keep it as 3. And let me go to properties and set the output response. So the top generated response, I already have the variable because I created the flow before. It's the search response, it's a text variable, and I'm going to use that to generate a response and show here. And yes, so there can also be scenarios where you can actually, once you get the data from your context grounding, you also have an option to do this citations. So let's see how that looks like. So citations means that the data that you get from relevant sources, it will provide you with some information that it actually came from this document in this page. Yeah, so this is the basic configuration, and let's say temperature, I want it to be creative in generating my response. So that's it. So this is the simple flow, and let's run now and see. So in terms of the question that I could ask, so we all were looking at research papers. So one question that I could ask is like, who are the authors of a specific research paper, or what kind of research papers you have? Research papers you have. Two. So let's see what it generates. My response should be in a message box. Let's give it a couple of seconds. Okay, we have the breakpoint here. And I want to show you, before I show the response, let's actually look at the data. Okay, this is the search response. Okay, it has some information here. Let's see what that is all about. Okay, so I loaded two databases, like two documents, and here is giving me, yeah, so all this content is actually from the same two research papers. So there were all this information in that. I read it before. And you can also see it also gives you the document ID, depending on where it is. Now let's try to generate another specific response. Um, I want to know the authors of this research paper. Authors means the guy is mentioned over here. I think it didn't copy. Okay, let's see. Okay, I have the breakpoint, and here's the response. Let's go back to our, yeah, so I think we have the same names. I can see this guy. Yeah, so all the names are here. And you can also see the source, the citation, the source, the name of the document, and from which page it is coming from. So this information is relevant when you're actually searching for information that you don't know where it is. This citation can actually help you to manually go there and find these data sources, which you may need to do some actions based on that. So that covers this topic. And I hope this is helpful to understand how what context grounding is and how it is relevant, and how to implement a simple RAG solution within UiPath using UiPath Context Grounding. So this is the first step. As you saw, there are other areas that we need to focus while doing this recording. So I will follow up on those topics in the other videos. So thank you for watching, and I'll see you in another video.